presented by New Discoveries in the Advanced Interface of Computation, Engineering, and Science. What is deep learning? As young children explore their world, they learn to recognize objects by trial and error. A child may see an object and say, "ball." A parent confirms if the child is correct. Looking at another object, the child may again say, "ball." If the child is incorrect, the parent will say so. "That's a puppy, not a ball." After many trials, the child eventually internalizes what is and is not a ball. Deep learning is a type of artificial intelligence that also uses trial and error to help a computer program recognize objects in a category. We use deep learning when the features of an object are difficult to describe to a computer program. Through trial and error, we let the program figure out what features an object has and which features are more important than others. Deep learning is a process where a program learns by experience, just like young children. So how does deep learning work? Well, deep learning requires two things: a data set and a neural network. First, let's talk about data sets. As an example, a data set for an image recognition system would have a series of pictures with labels correctly describing the picture. It is not unusual for a data set to have between 50,000 and 100,000 images and labels. A neural network is built out of a series of layers of nodes. It has one input layer, multiple hidden layers, and one output layer. The deep in deep learning refers to the number of hidden layers. The more hidden layers, the deeper the neural network. Each node in one layer is connected to each node in the next layer. Some connections are more important or weighty than others. Data from the image enters the neural network at the input layer. Each node computes its output based on its inputs and the weight of the connections from those inputs. The result at the output layer is a prediction of which label should be associated with the image. To improve accuracy, the system adjusts the weights on connections and reprocesses the entire dataset many times. If the predictions become more accurate, we say the network is identifying features and learning which features are more important. Most people don't know that computer applications with deep learning are already part of our daily lives. Some provide entertainment, while others simplify our lives. Video games are a fantastic example of applied deep learning. Ever heard of an NPC? It means non-player character. Some games use deep learning to control NPCs. As the game is being developed, a video is recorded of a game screen with a person controlling a character. The video is divided into individual image files. The images are labeled to indicate what button the person was pressing at that time. A neural network is trained to predict the button pressed with each image, and then incorporates that into the movement of that NPC. This results in a better game experience where NPCs behave more like people since their movements are based on a real person. Deep learning is also being used in self-driving cars. Just like normal cars, self-driving cars need to stay in their lane on the correct side of a road. Sometimes this is done by training the neural network based on how a person drives a car. A forward-facing camera records the road from the perspective of a car driven by a person. At the same time, another device records the angle of the steering wheel as the driver moves through traffic. The video is divided into image files that are associated with the steering wheel angle at that time. This data is used to train a neural network to drive a car without explicitly teaching the car to recognize lane edges, crosswalks, or other traffic control markers. That's just the beginning of what deep learning is capable of. Companies like NVIDIA use it to train virtual robots inside digital twins of real-world factories. This saves companies millions of dollars since mistakes are easily fixed. Engineers just copy the virtual robot's AI to a physical robot when the factory is ready. Doctors are using neural networks to diagnose diseases, while scientists use deep learning to predict earthquakes better. Even the filters on our phones use deep learning. It's literally everywhere. So, now you've learned about deep learning, data sets, and neural networks. But that's only scratching the surface. Want to learn more? Then click one of the thumbnails in the video or visit us online at our website.